everyone, welcome to the channel. In this project, I will work on the most popular books from 10 different genres based on the number of times they have been shelved by the users on the Goodreads website. This project is actually part of an assessment for my postgraduate studies under the data visualization subject. There will be 2 videos in this project. In this first video, I will show the process of collecting the data, and in the second video, I will show the plots that I have created using this data. In this project, I collect the data using the web scraping method. To those of you who don't know, web scraping is the process of scraping or extracting data from a website. To some websites or organizations, this is considered as slightly unethical because we are getting their data without their permission. In other words, web scraping is somewhat similar to us pirating the data instead of obtaining it through the website's API, for example. I chose to collect the data using the web scraping method instead of using Goodreads API because I want to improve on my web scraping knowledge. I will be using the R programming language for this project as well as several R packages, specifically RVES and Tidyverse. So let's begin. So the first thing that we're going to do is we're going to load the libraries and packages that we will be using in this project. So for this first part, for the web scraping process, we'll be using an art library called RVES. This is a package that contains all the functions needed to scrape the website that we want to collect the data on. Another package that we will be using is called Tidyverse. Tidyverse contains packages, some art packages or libraries that are useful when we're trying to clean our data, such as the ggplot2 package for data visualization, the dplyr package for data manipulation, stringr package for playing around with strings. Those are the packages that mostly we will be using for this part of our project. But the first thing, you have to make sure that these 2 packages are already installed in your R directory. One way that you can check is by running this library function. But if you're sure that you haven't installed the packages just yet, you can do this by running the function of install.packages and put it inside these 2 quotation marks here, the name of the package that you want to install. If you're going to install more than one package, you're going to have to use this C function as if you're trying to create a series of vectors. A shorter way, a quicker way to install these packages is by going to this Tools tab up here in RStudio and click on Install Packages, and this window will pop up and you have to specify the package that you want to install, for example RVES, and click on Install, the Install button. But since I already have these packages installed, so I don't need to run this code. Instead, I just run the library code. So now that we have installed our libraries, we can start with our web scraping process. And we're going to scrape the 50 most popular books from the Goodreads website based on 10 different genres. So let's first create a vector containing the list of genres that we are interested in looking at. So the ones that I'm interested are biography, crime, historical fiction, fantasy, horror, mystery, romance, science fiction, thriller, and young adult. So these are the 10 genres that I'm interested in looking at. And another vector that we can create is a series of URLs of the web page that we want to scrape. So for example, this is what I'm showing right now is the web page for the most popular crime books, 50 of the most popular crime books on the Goodreads website. And we can copy the URL and paste it in this vector right here. We can basically use this same URL. It's not the same URL, but basically we can just change this back part over here so that we can collect all the 10 URLs that we are interested in scraping. So since we're going to scrape 10 different genres, we are going to be using the same functions for 10 times for those 10 different genres. So it's going to be a long and tedious process if we're just going to be using it over and over again. So one of the ways that we can use to reduce the time it takes to scrape all of these websites is by creating a function, and we can just apply that function only once, and the output for that function should be a data frame or a data set completed with all the information that we need in our for our analysis. Going back to this web page right here, so the information about the books that I'm interested in looking at are the title of the book, the title right here, the author of the book, the number of times the book has been shelved by the users, the average user rating, the number of votes or ratings the book has received from the users, and lastly, the year the book is published. So there are 6 of these, and one thing we can do is by installing an extension, a Chrome extension called the CSS selector, called the selector gadget, which helps us in locating the CSS selector. This is actually important because we need the CSS selector in order to scrape our website. So now let's create our function. Let's call our function as scrape, and it will take 2 arguments, which are the URL of the web page that we want to scrape and the name of the genre of the book or the books that we are going to put in our data frame. The output for this function is a data frame containing all the information or all the 6 columns that I've mentioned that we will be scraping from the website. So the first step in web scraping is to read the HTML of the website, and to do that we will be using a function from the RVES library, which is the read HTML function, and the argument is the URL. This is a string, actually a string. Basically it's the URL of the web page that we want to scrape. We're going to put this inside a variable called web page, and this variable web page here will be the argument for our second function, which is HTML nodes. It will read the web page, and then it will also look at the CSS selector for the information that we're interested in scraping. So for this, the first information that we're trying to get from the website is the title of the book. And what we're going to do is go to our web page here and open this selector gadget extension and click on the title of the book. We can see here that the CSS selector for the book title is this one right here. Basically, we just copy this and paste this, put this inside the double quotation marks, and then we're going to convert this into like a human, some sort of a human readable text. We're going to use a function called HTML text, and we pass the title argument here, which we have extracted here using the HTML notes function. So let's try to see this outside of our function, just so that you can get a clear view of what we're doing so far. So it's read_HTML and the URL. Make sure that you put this inside. If you're running this outside our function right here, make sure that this is the URL is enclosed inside the double quotation marks. And as you can see in our console right here, this is we have successfully extracted or scraped the title of the books, the 50 most popular books under the crime genre. So this is what these functions have been doing so far. We can repeat the same process to get the name of the author of the book. Notes, web page, and as for the name of the author, we can click on the name of the author here, and as you can see, some of the other CSS selectors, some of the other things here in this web page is selected as well. We can unselect this by clicking on any one of these highlighted texts right here. So now we get the CSS selector for the names of the author, and paste this right here. Once again, let's see this outside of our function so we can have a clear view of what we are doing right now. And once again, let's look this in our console. And here are the 50 authors, the authors for the 50 most popular books under the crime genre. So far it has been, an easy process. Getting the title of the book and also the name of the author so far has been easy, but for the rest of the information, such as this, the number of times the book has been shelved, the average user rating, number of votes, and the year the book is published, this is actually going to be a bit of a lengthy process right here. So let's repeat what we have done so far and simply just put the information into X right here, HTML notes, web page. And as you can, if you try to see here, when we try to select the number of times the book has been shelved, we see that even the other information that we're interested into looking at are also selected as well. It's actually, in a way, this is actually easier because we can just use this function, all the HTML notes, these HTML text functions only once, just to get all the four information, the rest of the information that we need. The problem, it's not a problem, but it's more like the complicated part definitely has to be how we're going to separate them. Here, let me show you first. We take a look at the first few observations for X. We see that the odd elements, every odd value inside X here, the first value, the third value, the fifth value, they contain the number of times the book has been shelved. Whereas For the second value, the fourth value, the fifth value, basically the even values or the even elements inside X here, they contain the rest of the information that we need. So what we can do is we're going to split X here into two separate vectors, one containing the number of times the book has been shelved, and the other containing the three information, the rest of the information that we need in our data set. The first thing that we're going to do is we'll try to remove this \n value here, which indicates the next line value. We'll remove this by using a function called gsub. Put it back into X. The gsub function, and we're going to substitute. Basically, what the function does is we're going to substitute this \n values here with an empty space character from the vector X right here. We try to look at X once again. We see that those \n values have been removed. The next thing we're going to do is we're going to split the strings here into individual words or individual strings, and we're going to separate them based on the space in between these strings. The function that we're going to use here is called strsplit. For vector X, we're going to split it based on the space in between the strings itself. So let's show what the output is. As you can see, the output is in the form of a list, and in each list it contains the strings of the original vector here. The first value here says shelved 4041 times as crime, and so the first element inside this list, this new list, basically have the values of shelved 4041 times as crime. Basically, they become individual strings from the original sentence right here. And now, as I've shown earlier, every odd element inside of X contains the number of times the book has been shelved, and the even elements contain the rest of the information. So we are going to split them into two separate lists, one containing the odd elements and the other containing the even elements. And first, what we're going to do is we're going to subset them using the sequence function. Let me show you first. Sequence function, starting from 1, ending based on the length of X, and the increment is 2. So when we use this sequence function with these values inside as the arguments, we get a series of odd numbers starting from 1 and ending at 99. And to get the sequence of even numbers, all we have to do is just replace 1 here with 2, and here we have a series of even elements. So we're going to subset X. Let's call one of the lists as X1 X, and in square brackets we say sequence 1 until the length of X and increment of 2. The other list is X, we call it as 2, and we'll be subsetting it using the sequence of length X starting from 2 and increased by 2. If we look at the first few observations for X1, we see that they contain the number of times the book has been shelved. As for X2, we see that they contain the rest of this information. So basically, for now, our subsetting has been, a success. So far what we have seen here is that our subset has been a success. So the next step that we're going to do in handling this part of the web scraping process is to create 4 empty lists contain for the rest of the information that we're trying to get here. So this one here, shelved, will be the number of times the book has been shelved, and we'll set it into null. The average user rating, the number of votes the book has received, and the year that the book has been published. So these are four, let's say that they're just four empty variables. That's why we put them into the null value. Now we're going to use a for loop to extract or to get the values of the information that we need. So when we take a look, okay, let's try to take a look at X1 again. And we see that in X1, the value that we want, which is the number of times the book has been shelved, it is the second value inside each element of X1. So what we're going to write here is a for loop for I in the range of 1 until 50, which is the number of books in this in the original list. We're going to extract from X1 inside each element the second value from each element right here. As for X2, as for X2, we see that the average user rating, the value for the average user rating is located at the 19th value. It is the 19th value inside each element in the list of X2. So for the average user rating, we'll extract from X2 the 19th element inside each element, the 19th value inside each element of the list X2. For the number of votes, it's this one right here. And if we see from the value, the index here, ratings, the word ratings is 37, so that makes the number of votes to be in the 36th value inside of each element. And lastly, the year that the book is published, this one right here, is the 56th value inside each element of X2. So now that we have extracted all these values, what we're going to do is we're going to append them or add them to the empty lists, these four empty lists that we have created earlier. We're going to use the append function to do this. And once again, we'll try to run this outside of the body of our function so that we can have a clear view of whether our extraction has been successful or not. Let's take a look at shelved, and we see these are the number of times, the values here are the number of times the book has been shelved, the average user rating, the number of votes each book has received, and the year that the book is published. So when we take a look at these four information, these four values that we have extracted, we see that they are enclosed inside these quotation marks here, meaning that they are either in the data type of character or factor. We can check by running this str function right here, let's say on shelved, and we see that it is actually in character data type. We obviously want this to be in numeric values, so what we're going to do is we're going to convert them from character data type to the numeric data type. We'll add this in our function for shelved. The function that we will be using is called s.numeric shelved. Same goes with the average user rating as well as the year that the book is published. If we run this code and run str shelved once again, we see that it has been successfully converted into a numeric format. For votes, however, when we take a look back at our votes vector right here, we see that the number of votes the book has received, they have this comma value in between them, and this comma value actually hinders us. It actually prevents us from converting it into the numeric format, because if you try to type as the numeric for votes, we see that it produces a list of NA values, and there's a warning message right here. NA is introduced by coercion. So yeah, like I said, this is actually because of this comma value right here, because we're trying to force a character data type or a string into becoming a numeric, so it's not going to work. So what we're going to do right now is we're going to split the values here based on the comma, and we're going to paste them back together. Basically what we're going to do is we're going to remove the comma values in between these values right here. We're going to remove the comma from the values, each of these values here. And to do that is, yeah, like I said, we're going to remove them, split them into two separate or three separate values using the str split function, and then paste them back together using the paste function. So the first thing that we're going to do is use the str split function, and we're going to split the values inside this votes vector right here based on the comma. And if we run this and see the first few rows, and we see that it has been successfully split into, either 2 or 3 strings based on the comma in between them. So this first book right here, it has received over 2 million votes from the users, so therefore it is split into 3 values. For the second book, it only received 800,000 votes, so it only splits into 2 characters right here. So basically the paste function, it will take the arguments are the strings that we want to paste together, and it doesn't matter how many strings that you want to paste together, as long as you specify all those strings before the set argument. So here, let me show you. Let's say that we want to paste this first element of votes right here. So what we do is use paste votes of 1 votes of 1, the second value, and the third value of the first element inside the votes list, and we're going to separate them using with no space at all. So this is actually what we're trying to get at the end of our paste function right here. So to paste together all 50 number of votes here, we're going to use the for loop again for I in the range of 1 until the length of the list of list votes, and here we're going to use an if-else statement. If the length of the elements, the length of the values inside each element, inside the element of votes here, is equal to 2, therefore we're just going to have to paste only those 2 values together using this command right here. separated with no space at all, and we're going to put them back as individual individual elements inside of the votes list. Else, we're going to paste together all three values inside each element of votes. Separated with no space at all. So let's try to run this for loop and see whether it is a success or not. So yeah, this is the output. And now that we have successfully removed that comma, we can now convert the number of votes here into the numeric format. So we can add this to our function. Now we have successfully collected all the seeds information that we want from the Goodreads website. So the last step is to create this data frame, the output of our function right here. And to create that data frame, we'll be using the data.frame function, and we're going to specify the names of the columns that will be included in this data frame right here. The title of the book, the name of the author, the average user rating, the number of votes, the year the book has been published, and the number of times the book has been shelved. So since we're scraping 10 different genres, we definitely have to specify that the books containing in our dataset is in which genre. So here we're going to use the genre argument that we have included as an input for our function right here. So basically all it does is it lists down the genre of the book 50 times. It will repeat the name of that genre 50 times. We will see this in an example later on. So basically this is all that we are going to have inside the body of our function. So the output of our function, as I mentioned, will be this data frame right here. So yeah, this completes the function that we have created for our web scraping process. So earlier we created two vectors that contains the list of genres, containing the 10 genres that we will be looking at for our data, and also the URLs of the web page that we want to scrape. So we're going to apply our function scrape here on these two vectors using a function under the per_r package, if I'm not mistaken, called the map_to_dfr function. Let's try to have a look at the documentation for this function right here. So yeah, it is under the per_r package. So it will iterate over multiple arguments simultaneously, as it says here. It will take those two, in this case, it will take these two vectors that we have created earlier, and we specify the name of the function that we're going to apply over those two vectors, and it will create an output in the form of a data frame. So let's try to run this function using those two those two vectors that we have created earlier: URLs, genres, and scrape. And we're basically going to put them into a data frame, and let's call that data frame as data_books. And we're going to run this. It will take some time to run this function because it will be scraping 10 different web pages. So we'll come back once it has finished running. So now the function has finished running, and you can see here there is a warning that says that it says here there were 23 warnings. Use the warnings function to see them. Let's try to have a look. We see that there are some parts of the dataset. There are NA values. NA is introduced by coercion. If we try to have a look, we see here that this book right here by John Tiffany has NA values in it. Same goes with this book here by William Goldman, and it has NA values in it as well. This can be, there's actually, I actually cannot explain why these NA values are introduced inside the data into our data set, because in my original project as well, the NA values existed here in the data as well. So what I'm showing here is the original R script for my project, and as you can see, there is a section right here where I mentioned that I have to manually fill in the missing values, meaning I have to go back to the website and look at the ratings, the average rating, number of votes, the year, and the times shelved for each of the books where the information is missing. So for now, let's just ignore it and continue on with our web script. In our progress. Let's take a look at the title column for our data frame. We see here that since it mentions here 405 levels, indicating that the title column is in the data type of factor, and what I'm trying to show here is that the titles, they contain this extra information at the back here, such as this book by Miss Peregrine's Home for Peculiar Children. It mentions here that it is the first book of the series called Miss Peregrine's Peculiar Children. The same goes with, for example, this one right here, City of Glass. It is the third book in the Mortal Instruments series. And there are also other information, such as for this book Speak right here, it says hardcover, meaning that the edition or the version that most users have been shelved in are in the hardcover format. For me, I'm not actually interested to know about all of this, and I really hope that I want to remove this extra string right here at the back. So what we're going to do now is to use pattern matching with regular expressions to remove this extra information here from the book title. For me, the topic of regular expression is kind of a bit complicated, so I'm not exactly sure how I can best explain it in the most simplest term, but I'll try my best. I'll include extra information that I refer to, or the resources that I refer to when I try to remove the extra characters here using the regular expressions. I'll include the link to those resources in the description box below. And if you have any questions, or if you're not clear on the certain parts of this section, feel free to ask them in the comment section, and I'll try to answer them as best as I can. Or if anyone else wants to answer it on behalf of me, that would be great. Okay, so let's try to get on with it. So what we're going to do now, to remove this extra string at the back of each of the book title here, is we're going to substitute this extra string, these extra characters here, with an empty space. And to do that, we'll be using the gsub function. And as you can see, the arguments for the gsub function is the pattern that we're trying to match, and the replacement which in this case is the empty space, and x, our vector, the vector containing the string that we're trying to replace here. So first, before we run this gsub function, let's try to use the strView function to view the pattern matching using the regular expressions, so that you can see clearly what it is that we're trying to remove, whether the pattern that we will be including inside the gsub function will hopefully remove the string at the end of our title here. So the first argument is the string, or the vector, in this case the vector that we're trying to work on. In this case it is the title of the books, and we have to make sure that it is in the character format. And the second argument is the pattern that we're trying to look for, that we're trying to match here. So based on my research, this is the this is the pattern that we're trying to look for right here. Okay, so I'll try to explain the meaning of this pattern as best as I can. This \s here means that we want to remove, we're trying to look for any extra white space between the strings. The white space can either be the space or a tab or a next line, and this one right here, because the parentheses or the brackets here, the round brackets here, are considered as meta characters in regular expression, meaning that they have they actually play a part in regular expressions. Since they are considered as meta characters, we're going to have to include a \, before each of these brackets here, because obviously our string here begins with this round bracket here. If we don't include the \, it will not find this opening bracket here for the extra string that we're trying to remove. And for this part right here, inside this square bracket, this means that we're going to look for any characters, all the characters that are contained before this closing parenthesis here. And the plus sign means that we're looking for any occurrences, one or more occurrences preceding this all of this pattern right here, if I'm not mistaken. Do correct me if I'm wrong. Once again, we're looking for any extra space, and also this $sign means that we're looking at the end of the title, at the end of the string. So that is basically what this pattern does. I hope you guys understand that. Even I myself get confused with this as well. So when we run this, we see that this is actually what we're trying to remove here. So that means this pattern right here works to remove this extra string at the end, at the back of our list of book titles. So we can add this pattern right here to the gsub function. We're going to replace this pattern here with an empty space, and we're going to use it on the title column. So when we take a look again at the title column, we see that the extra information, the extra string at the back has now been removed. So it contains the basic title, the original title of those books. each of the books inside those 10 different genres. Besides the those seeds information from the books that I collected, I was also interested in looking at any adaptations or media adaptations of the book, whether the book has already been adapted into a movie or a TV series or perhaps a documentary or a stage play. So those are the things that I'm also interested in looking at as well. So for that second part, I refer to the IMDb website and collected information on whether the books here have been adapted into into movies or TV shows and the rest. So the results of that extensive research that I conduct using the IMDb website and perhaps the internet, or just the internet in general, to look for whether any media adaptations of these books exist or not, I put them inside this text document right here, and I've already put them in the form of an R code. Basically, they're just vectors containing whether for this first vector right here, it says adapt, meaning whether the books have been adapted or not. The second vector here is rating adapt, meaning the rating of the adaptations of those books out of 10. So if it is NA right here, it means that either the adaptation has not been released yet, or there are no adaptations of those books. Votes adapt here stands for the number of votes, or the number of votes that the users has voted, that contributes to this average rating right here. Next is year adapt, which stands for the year of the adaptation. And lastly is type adapt, the type of adaptation that the book is. For example, the first book has been adapted into a movie. The third book in the dataset has been adapted into a TV series. So what I did next is I copied all this information and paste them inside the console. And then, using the cbind function, I bind them together into the original data frame that we have created earlier, data books, and we bind them by specifying the name of the vectors that we have pasted inside this console right here. And put them back basically inside our data frame, data books here. So when we take a look at the first 6 rows of data books, you can now see that for the book Steve Jobs here, it is written by Walter Isaacson, has an average rating of 4.14 out of 5. The number of users who have voted for this book is 979,433. The year that the book is released in 2011, and it has been shelved 6,000 times by the users, and it is under the biography genre. It has been adapted into a movie, and this year adapt here is a bit wrong here. I forgot to mention that this actually is for the original dataset or the original website that I have scraped, and actually there has been a change in the list of books between the time that I first scraped them back in July and now is December. So obviously the titles of the book has been rearranged. Originally, if I'm not mistaken, the Diary of a Young Girl here is actually the first book in the list. The Diary of a Young Girl by Anne Frank, and it has been adapted into a movie back in 1959. So that is actually the correct value. But so basic, other than this little mistake here, it's a little mistake here. Other than this mistake, basically this is what I did for the project. So the final step is to export this dataset, data_books, as a CSV file, which is saved in the current working directory. Using the write.csv function, we're going to export data_books as a file called books.csv. And since we're not going to take in these index values here, 1, 2, 3, 4 until 500, we don't want this index value to be included in our CSV file, so we're going to specify the argument row.names as false. So I'm not going to run this code because I think I've already mentioned that I'm going to be using the original dataset for the second part of this project, which is the data visualization project. And obviously, as you can see right here, there is incorrect information here about the books and the adaptation. So if I want to continue using this dataset for the next part, I may have to fix the rest of the columns that I've just added about the adaptations, because like I said, the title of the books the ranking of the books have changed ever since I originally created the dataset. So that is the end of the web scraping process. In the next video, we will work on the data visualization of the dataset that we have just created. If you have any questions or there are parts that you don't understand, feel free to drop them in the comment section and I will try to answer them as best as I can. If you enjoyed this video or you might have learned something new from this, please give this video a thumbs up and subscribe to my channel for more contents like this in the future. Thanks for watching.